Welcome to the Databricks Skill Builder series. We're glad you're here.
All right. Well, thank you everybody for joining. Today we're going to be talking about networking on AWS with our Specialist Solutions Architect, JD. JD, you want to take it away?
Yeah, absolutely. Hey, everybody, my name is JD Braun. I'm a senior specialist solutions architect in cloud infrastructure and security. And today we're going to be talking about how to change your networking configuration for a workspace on AWS. So before we go into it, to not make this the shortest skill builder video that we have, just going to give some context of what's in a workspace, talk a little bit more about the networking configuration and why it matters. And then we'll go ahead and go through a quick demo on how to do that, both how to do it within the console and how to do it within Terraform. So we're going to start off in the whiteboarding screen, and then we'll move to a couple of other ones. So bear with me as I switch around the share screen a little bit. All right, so let's go ahead and get into this. So first things first, when we think of a Databricks workspace, what are the components that go into it? So a Databricks workspace can have a few different components. The first component or required component is what we call a storage configuration. Not to be confused with a storage credential or an external location that are Unity catalog concepts, a storage configuration equates to a single S3 bucket that is in the customer's environment. This S3 bucket is where when a user is interacting with the workspace, maybe they're using jobs or queries or other assets like MLflow, different artifacts are written to this bucket. It's nothing that the user needs to do. It all automatically happens on the back end, but really just various assets that are stored from the control plane, so the workspace and everything, written into this single bucket. The next thing that's in a workspace is the credential configuration. The credential configuration equates to an IAM role. This IAM role allows when users or other entities go into the workspace or interact with the API to actually spin up the underlying clusters within an AWS environment. Now, this is specific for our classic compute plane and not equivalent to serverless. So this IAM role is specific to spinning up underlying EC2 instances for the classic compute plane itself. This has a specific trust policy as well as specific IAM role associated to it. And again, at the end of the day, it just allows EC2 instance to spin up when a user or a process needs a cluster to process data, run a machine learning job, or anything like that. The next thing that a workspace needs is a network configuration. That's what we're going to be talking about today. The networking configuration is basically what you're telling Databricks to deploy the compute into. So this includes a VPC, a couple subnets. You can have as many as availability zones in that region, or minimum 2, as well as the security groups. So you can think about these as the firewalls that surround those instances with specific ports that open up. And that's it. There are 3 basic items that go into it. If you're on enterprise and you're using private link, you'd also specify your private link backend connectivity in this spot as well. Before we dive more into the network configuration portion of it, you can also include in a workspace some encryption options as well. So you can include encryption options for our workspace storage, that's specifically tied to the encrypting objects that are sent to this S3 bucket that we talked about earlier, as well as the EBS volumes that are associated with the EC2 instances in the classic compute plane. And then last, you can specify encryption for managed resources. So this is for a designated set of services that reside within the Databricks control plane itself. So like secrets, for example, that you can encrypt them within the Databricks control plane. The full list of it is available, and both of these correspond to a single or multiple KMS keys. So some context of everything that goes into a workspace so that you can start processing data, like I mentioned, run ML jobs and things like that. Now let's go ahead and dive a little bit deeper into this networking configuration. So for those who've been working with Databricks for quite some time, there are two ways that you can deploy a workspace to set up this underlying network. The first is what we call a Databricks Managed VPC. This Databricks Managed VPC is where Databricks, using that cross-account role that I mentioned earlier, is actually going to spin up all of the underlying assets for you. So it's going to spin up the VPC, it's going to spin up subnets, it's going to spin up your security groups, etc., all within your AWS account. So when you go into the console, you click on the top right-hand screen, say Quick Start, and you specify it, a CloudFormation template comes up, and then they'll spin up, when you run that template, it'll create the VPC, subnet, everything for you. Now, if you create a workspace with a Databricks Managed VPC, you're locked into that Databricks Managed VPC concept. When you see your workspace in the console, you actually won't see a networking configuration box at all. They'll be managed by Databricks under the hood within your cloud environment. Now, for folks just getting started with Databricks, this is an awesome opportunity, especially if you're maybe coming from the data engineering background, maybe you're just testing it out, maybe you're a data scientist that wants to get rolling, so you don't have to handle any of the underlying networking components yourself. Just one click and you're there. It can be very helpful. It's entirely viable and great to use. Now, for the majority of customers that I work with, though, their AWS account and their underlying network is typically owned or operated by another team, such as a networking team, a DevOps team, etc., where they already have their AWS account set up. And in that, maybe they have, one VPC that's for their data workloads. They have another VPC that's for their front end applications, etc. And each of these VPCs has mapped IPv4 space and everything that's in a tight, nice architected area. So in this case, for deploying Databricks, just going ahead and spinning up a net new VPC with all subnets, etc., may not be a viable option. Or, like I talked about before, they want to integrate private link as well, which is only available using customer managed VPCs. So in that case, for a workspace, you can specify all of those assets when you create it. So you're going to be using a customer managed VPC, and whether you're using Terraform or API or anything like that, you're going to be giving Databricks, when you put in the resource or the API call, you're going to be giving it the VPC ID, subnet IDs, the security group IDs, as well as potentially private link as well. So all of those coming into creating one concept of this network configuration. So all of these areas together is what make up this original box of the network configuration of where you want the workspace to be deployed and the assets to be deployed to. Now, in the process of when users are using Databricks and going about their day-to-day jobs, they may deploy a customer managed VPC into an initial subset of subnets or initial VPC or something like that. And they're going around their day-to-day job, and all of a sudden, hey, my clusters, I can't spin up anymore. That's because each node of a cluster requires 2 private IPs. So if you create a customer managed VPC to begin with, maybe it's a little too small, and you start running into these errors, you realize, oh, I need to spin up a new, larger VPC to support my workloads. So that goes to the context of today's conversation, is how, when you have this customer managed VPC logged as this network configuration, how do you switch them on a workspace? And what does that look like? Because it's an important thing that comes up quite often is, hey, you may start with a workspace with X CIDR range of the VPC. Maybe it's a slash, 24. It's a little bit on the smaller side and you want to scale up. You can do so using two customer managed VPCs and switching that underlying networking configuration using the APIs or Terraform. So let me share my account console screen and let's go on what this actually looks like out of the whiteboard and into the account console. All right. And then, Stephanie, are you able to see the account console?
Yes.
Perfect. Awesome. So within the account console, this will be something that y'all are familiar with if you're active Databricks customers, is this is where you're going to have the central location for all of your workspaces. So I currently have one. I have my skills builder network patch workspace. And this workspace is going to have that credential configuration like I talked about before with that cross account role that allows me as a user to spin up clusters. And it's going to have that storage configuration, which is going to be that S3 bucket that these assets are written to. And then most importantly, the star of the show is the network configuration. This network configuration is going to have my VPC ID, my subnet IDs, and my security group IDs. So what VPC I'm deploying into, what subnet I'll be deploying to, either one or the other, depending on the availability. And then the security group, so that firewall that's associated to the EC2 instance that allows outbound connectivity to certain ports. So maybe that's HTTPS connection, maybe that's the Hive Metastore, etc. All these assets make up a customer managed VPC in the form of this network configuration. Now, if we take a look at my AWS console and we go into the VPCs, this is the VPC I'm currently working with. I'm working with 172.0.0/18. Now I'm doing my day-to-day work, I'm operating, I'm going through and I'm processing all this data in S3, I'm creating all of these new data assets, everything. But then I get a new request saying, oh, I need you to read from this database. Sounds great. I take a look at the database and then all of a sudden I see that it has the exact same CIDR range as my private subnets of my Databricks assets, meaning they can't talk to each other if those CIDRs are overlapping. So you're thinking, oh no, what do I do? So in this case, what I've done is create a net new customer managed VPC using a 10.0 CIDR range with the associated subnets. So the reason that I need to create a net new one instead of just updating, say, this one, is that these network objects in our current general availability are immutable. Is that you can neither add nor subtract or change the VPC that exists with them. So it always needs to be a new network configuration if you're going to be switching them. So if I go up here, in some of these other assets, you're going to see change or destroy or anything like that. In this case, it's going to be just the delete network configuration. So what happens if I try and switch it out or try and change it by just updating the subnets? So I'm going to go ahead and share a new screen and go ahead, Stephanie, let me know if you're able to see my Terraform code.
Yep, you're good to go.
Perfect. In my Terraform code, I have defined these network configurations in two places. I have my first one, which I'm currently using, which is just where I've registered it, getting the security group, the subnet, the VPC ID, etc. And then I have my net new one, where I'm going to say the network, the security group, subnet, etc. So these are the two ones that I've created so far that are currently residing in my account console. So let's just test something out. What happens if I take my resource and I just update the VPC ID within the one I'm trying to replace? So this would be kind of a net, hey, have my network configuration. Let's just try and switch the VPC ID out from it. So I'm going to go ahead and pop into my terminal here. And I'm going to do a Terraform plan. And it's going to go and it should check that, hey, something's changing, specifically that VPC ID, that would be different. And all of a sudden, I'm going to be getting, hey, the network must be replaced. So this is showing that you have this current network configuration, you're trying to change it, it's not a patch call, and it's going to be deleted. So I'm going to say, that sounds fine, right? The workspace may be updated in place, like this sounds great. I'm going to go ahead and do my apply. Hit yes. And then this is the error that you'll be running into. Because this network is associated with the underlying workspace, it's going to automatically throw and say, hey, you can't update this because they're intertwined together. Is that because the network object is immutable, you're not going to be able to switch it underlying from the workspace because there's that dependency between each other where you can't just go ahead and remove the network from under it and replace it. You got to swap them at the same time. Think Indiana Jones style, right? Where Indiana Jones is sitting there, he's trying to grab the artifact, he's weighing it up. If you just take one off, Boulder's going to come through. So you got to swap them at the time so that the objects stay the same. Now we all know how that worked out for Indiana Jones, so hopefully it works out a little bit better for us. So I'm going to go back to my Terraform code here, and I'm going to go ahead and do my replace VPC ID, leave that the same way. But what I am going to do is I'm going to comment out my network ID that I have currently loaded, and I'm going to switch it with the one that I want. So switch it to that 10.0 instead of the one that I had before. Now I've saved that. Let's pop back to my terminal. Let's do another Terraform plan. So now what you're seeing is not that the network needs to be replaced, but only that the underlying workspace is going to be updated in place. Now, a big caveat before you hit apply is that all EC2 instances as well as clusters need to be shut off before you do this. So you can't run it in place as clusters are running, as you understand why that may cause some conflict of what's happening. So you need to terminate the cluster, and the underlying EC2 instances behind that cluster need to be terminated as well, which can cause a little bit of confusion. When you turn off the cluster, you try and switch it, you get the error. Make sure that you go in under the hood and see that the EC2 instances are fully shut off, because there is somewhat of a lag for cluster reuse. So here, I'm going to go ahead and do my Terraform apply. Okay, yes. It's going to modify the workspace. So this is going to change on the back end. And something important that once this has ran, hold off on spinning up any new clusters for about 20 minutes or so, just to make sure everything's been updated. But now this looks great. So I'm going to pop back here into my workspace. Let's go ahead and share. Go back to my workspace. And in my workspace, I refresh the page. And now you're going to see that the network has now been updated. So if I check the VPC ID ending in CDB, we're going to see it's been updated to that new network configuration. So very straightforward in how to change that underlying asset. Now, I use Terraform as an example. I know that not everyone may be familiar with Terraform, so this can easily be done in the console as well. If I go into my network or go to my workspace within the account console, I go into Update Workspace. I'm going to click Advanced Configurations, and then I can go ahead and switch it to another one. So this is going to be the VPC ending in 6C7. As you can see, that's the one we just switched from. So it can occur either in the Terraform, or can be in the console, or you can use the API. A lot of ways to do this patch call as you're going through it. So with that, let's go ahead and summarize what we talked about today. So what are the components that go into a workspace? You have your storage configuration, which is that underlying S3 bucket that writes control plane assets. You have your credential configuration, which is that cross account role that spins up compute for the classic compute plane, or allows the Databricks to do so on behalf of the user or entity, the networking configuration, which like I mentioned was the star of the show today, of where assets are being deployed and what is applied to them, private link, security groups, etc. And then encryption options for workspace storage and managed services. We then talked about a Databricks Managed VPC, about how that's a good way to get started with Databricks. However, we see in many of our enterprise and production use cases where customers use their own customer managed VPC, where they can specify their VPC ID, their subnet IDs, their security groups, private links, etc. And then through that process, at some point, they may need to switch that out, the VPC out. I've used the examples of maybe the clusters were the size of the CIDR range was too small for the clusters that they needed to spin up, or maybe they needed to reach a database that had an overlapping CIDR. So switch it to another one that exists within the account console, either using Terraform or the API or the account console. Now, before I go here, I want to talk about some of the gotchas like we talked about before, and these are all documented within our documentation of updating a running workspace. So you can find that if you just Google that, update a running workspace, Databricks, you'll see the considerations there as well if you need to take these after this call. Number one, verify the existing network or the new network is functioning. What I always like to do and how I always consult customers that are making this switch is use your net new workspace and spin up another workspace, a dev one that you're just going to tear down, and validate that all your connections are correct. Validate that you can connect to the control plane. You can spin up instances either through private link or over your standard NAT to internet gateway, or however network device you have attached to the network. This can just save a lot of heartburn. If you do switch out the underlying networks, that you're not going to be stressed that, what if this breaks, what if this does? Always test in a lower environment. It's the safest way through it. 2, shut off all existing clusters. You'll get an error on this one, so don't worry about it. If you don't, they'll say like, hey, terminate all running instances before you switch. However, it's good for a down plan maintenance window. Probably not best at Tuesday at 1 p.m. when developers are going in it, a planned maintenance window of a Friday night or something like that, when you can actually run the pipeline to update it, because all clusters and all underlying EC2 instances need to be switched. And then wait 20 minutes. Wait 20 min before going swimming after, wrong advice. Before turning on clusters, again, after network switch. Again, just best practice here, making sure that everything has been updated on both sides before you're spinning up your workloads again to go forward. So that's it. Again, very straightforward, very simple in terms of actually updating the network. I want to give y'all some context on it beforehand. But of course, as always, this is all documented and go through. And if you're going through this, watching this video, if you have any questions, feel free to reach out to our community channel on Databricks support or your Databricks account team. And with that, that's all I got.
Thanks, JD.
All right.